welcome again. In this tutorial, we're going to learn about the question involving the moments of a force, that is the turning effect of a force. Now, we got the pivot at point D, and we have a pulley, and a force of 30 newtons is acting on the pulley, that is on the rope. Then we got another force at point A, and another force at point E. Now, in this diagram, we are going to determine which forces produces the clockwise moment and which forces are producing the anti-clockwise moment. Now, when you consider the force of 30 newtons, that is on the pulley now, when the rope is pulled downwards, so this rope moves upward on this other side. So now it is making the system to turn in the clockwise direction. So the force of 30 newtons brings about the clockwise moment. So this one is the clockwise moment. Now, the force at point A, that is force X. When the force is applied at X, it makes the system turns in the anti-clockwise direction at the pivot D. So this system is going to tilt in the anti-clockwise direction when a force is applied at point X. So this one results to the anti-clockwise moment. Now, at E, the force of 2 newtons. So the force of 2 newtons, it is directed downwards. So this force of 2 newtons makes the system turns in the clockwise direction. So as a result of that, it also contributes to the clockwise moment. Now, for us to apply the principle of moments, for a system in equilibrium, the sum of clockwise moments about a point must always be equal to the sum of the anti-clockwise moment from the same point of action. So the sum of the clockwise moment must be equal to the sum of the anti-clockwise moment. Now, to get the moment of a force is the product of force multiplied by the perpendicular distance from the point of action. So in this case, the clockwise moment force, we got 30 Newton. And the length of the rod E was given to be 40 centimeters. So it implies that from here to here is 10, and from here to here is 10. So the remaining distance from the pivot, this distance, is equal to 20 centimeters. So now we got the force of 30 newtons, and the distance from the pivot is 20. So that is the force, that is 30 newtons, multiplied by the distance, perpendicular distance from the pivot, from the line of action of the force. This one is 20 divided by 100 meters. Then we add to the clockwise moments, which is 2 newtons, multiplied by the distance from the pivot, which is 10 centimeters. That is 10 over 100 meters. This one must be equal to the anti-clockwise moment. So anti-clockwise moment, we only have one force, that is X. So X multiplied by the perpendicular distance from the pivot, 10 plus 20, we got 30 over 100 meters. So we got, so the value of X is equivalent to 20.67 newtons. So that is the value of X, the force acting at point A. Thank you.